So let's try some examples of some simple integrals. The integral of x cubed dx. Well, what was the x cubed before I differentiated it? What did I have to start from to get x cubed as my derivative? Well, the power must have been x to the fourth, because when I differentiate, I subtract 1 from the power. The derivative of x to the fourth is something x cubed. But what's the something? When I differentiate, I first multiply by the 4, right? So the derivative of this would be 4x cubed. I don't have a 4 here, so I actually have to divide by 4. And then I'm going to add my constant. Now, did that sound a bit like magic? Think of it this way. When you're differentiating, what do? When you're differentiating a power, you're going to, this is differentiation, you're going to multiply by the power and then decrease the power. So I started with, if I had started with something and ended up with x to the fourth, sorry, x cubed, I've got to get my things right, x cubed, that's differentiating. So for integrating, I'm going to do the opposite things in the opposite order. I'm going to first increase the power, and then I'm going to divide by the new power. X cubed becomes x to the fourth, becomes x to the fourth divided by 4. Does that make sense? Let's try a few more. I'll try and leave that at the top of the screen so you can see and remind yourself. What's the integral of x to the 7th? I'm going to increase the power and then divide by the new power. And I must remember to add a constant. What's the integral of the square root of x? Well, this is the same as x to the half. So that's x to the 3 on 2 divided by 3 on 2 plus a constant. Actually, I would normally write this as 2x to the 3 on 2 over 3 plus my constant. Let me make it a little bit harder, but not much. What's the integral of 3x to the 4th? Well, the 3 goes out the front. I've got x to the 4th, integral of x to the 4th is x to the 5th divided by the new power plus a constant. And I would normally write that a little bit differently. 3x to the 5th on 5, on 5 plus a constant. Or you might even write 3/5 x to the 5th. Or you might even write 3/5 x to the 5th plus a constant. Comfortable so far? Let's try one more slightly trickier. What's the integral of 4x root x dx? Now don't be afraid of this. It's not a product. Not really. This is just a power of x. It's really, 4x to the 3 on 2. It's 1 plus a half. So, leave the 4 out. X to the new power, 1 more than this, is 5 on 2. And I'm dividing by 5 on 2. But I'm going to write that a little bit neater. 2 times 4 is 8x to the 5 on 2 over 5 plus my constant.